Hey guys, welcome back to another edition of Geometry. It's Mr. A here with you, and today we're in section 6.4. We're going to talk about rectangles. Okay, so let's get going. Our objectives today, first of all, we're going to recognize and apply properties of rectangles. And secondly, we want to determine whether parallelograms are rectangles. Okay? All right, so we're talking about rectangles today. So the first thing, very important thing here, if you notice, that's why I put 3 asterisks right here, because it's very important. A rectangle is a parallelogram, okay? So we remember before we were talking about parallelograms, and we talked about a lot of things that were true in parallelograms. So all those things are still true of rectangles, because a rectangle is just a really special kind of parallelogram. So just to kind of quickly review, here were some of those things. First of all, since a rectangle is a parallelogram, both pairs of opposite sides are going to be parallel, just like a regular parallelogram. Both pairs of opposite sides are going to be congruent, just like a regular parallelogram. Both pairs of opposite angles will be congruent, just like a regular parallelogram. The consecutive angles, the angles right next to each other, will be supplementary, so that means they'll add up to be 180 degrees. And the diagonals will bisect each other. Okay, so all those things are still true in rectangles. So if we have a rectangle, we can still use any of those things to help us solve problems. Okay, but a rectangle also, here's the new stuff, again, also very important because of the 3 asterisks. First of all, a rectangle, what's different is it has all right angles. So right angles, remember, are 90 degrees. So all the angles in a rectangle are 90 degrees. So basically, a rectangle is just a parallelogram with 90-degree angles. Okay? So that's really important. Remember that rectangles have right angles. That's not too hard. The other thing, though, that's new is now the diagonals are congruent to each other. Okay, so before we said the diagonals bisected each other, they split each other in half, but the 2 diagonals might have been different lengths, but now those 2 diagonals are both the same length. Okay, so that's kind of a key thing. All right, so let's take a look here a little bit more in detail on this. So you can see here it says if parallelogram is a rectangle, its diagonals are congruent. So what that means is that from J to L, that distance is the same as from K to M. Those 2 are the same. In a regular parallelogram, think if you took this top part and kind of slid it to the right, they wouldn't be the same length. Those 2 things wouldn't be the same length. But when you make these 90-degree angles here, the 2 diagonals are the same length. So what that means, though, is this is still a parallelogram. So remember, the diagonals bisect each other. So before we said, oh, if they bisect each other, then I'm going to, let's see, J, K, L, M. I'm going to call this N in the middle so I can talk about it. So MN and NK are congruent. We talked about that before. But before, when we did this, we made 2 marks on these other ones here, JN and LN, because they're also congruent, but just not the same as these. But now that KM and JL are the same, now when we split it in half, all 4 of those short pieces there will all be the same. Okay, so that's really kind of interesting. So that gives us some new things to work with. We don't only have to compare like J, N, and L to make those equal. Now we could also say JN would also equal NK, or MN could also equal NL. So we've got a lot more possibilities there. The other thing is, if you notice, that's going to help us a little bit is, that's kind of interesting, is if you look at this, inside this rectangle are a bunch of triangles, right? 4 triangles that we've made up with the diagonals. And if you notice, since all of these 4 pieces of the diagonal are all congruent, what you have is you have a bunch of isosceles triangles in there. So this triangle over here to the right, since these 2 sides are the same, remember the angles across from those sides are going to be congruent. So for example, the whole thing is 90 as it's marked, but we know that that part of the angle and that part of the angle will be the same. Okay, that's kind of interesting. And also the way it works out is on the other side, it's the same thing where this one and this one are not only the same as each other, but also the same as the two on this side. So that's kind of cool. And then finally, if you look at these two other isosceles triangles that are kind of shorter and wider, same thing. It's an isosceles, so those two angles across from those two sides will be congruent, not necessarily to these other ones. So I'm going to put 2 marks, but those two will be the same. And the way it works out is on this side, those two will be the same as each other and the ones on the other side. So that's kind of another thing that's really kind of cool is all the different angles that are the same there. And of course, obviously, the thing that's really important is these two angles together. Any angle 1 and angle 2 together will make a 90-degree angle. So this one and that 2 makes a 90, that one and that 2 makes a 90, and so forth. Okay, so kind of cool. Let's look at some examples here. Properties of rectangles. All right, it says a rectangular garden gate's reinforced with diagonal braces to prevent it from sagging. If JK is 12 feet, let's write this in here. JK is 12 feet. LN is 6.5, so here's LN. This is 6.5 in here. Find KM. Well, where's KM? Let's see, KM goes from this corner all the way down. Okay, well, you know what? Remember, we could kind of look at this a couple of different ways, but it gives you the same thing in the end. One thing that you could do is you could say, well, if LN is 6.5, it must have been split in half, and so that means this other part here, JN, also has to be 6.5. So together, that would be 13, right? And since JL is congruent to KM, then we could say, well, KM would also have to equal 13 feet. I was a little sloppy there in my box. But you could have also said, well, if LN is 6.5, KN will also be 6.5, and then double that. Guess what? You get the same thing, 13. Okay, so you can kind of see a little bit there what's going on with a rectangle. Let's look at another one. All right, again, we have a rectangle. Let's fill in some things here. So we have GH is 6 feet, so there's 6 over there. FH, so this whole FH here is 15. Okay, I'm going to see if I can do this. Okay, so I kind of did that little squiggly bracket there. So that whole thing from F to H is 15. All right, find GJ. Well, GJ goes from here to here. Well, you know what? This is kind of similar to the last one that we did, right? Where we said, hey, if FH is 15, then GE has to be 15. So we could, we would say, well, if that, then GE would have to be 15. And so, what, JG is half of that, right? And so that means 15 divided by 2 would be what? 7.5. Okay? All right, now what about this? What about FG? Now this is a little bit different. FG, that's over here. Well, hopefully your first thought is, well, if it's a rectangle, that's a parallelogram, what's the side straight across from it? EH. Oh, we don't know that one either. Can't use that. So what else can I use? Well, here's where we have to kind of think back to some stuff we did before. Remember, since this is a rectangle, all the angles are 90 degrees. All the angles in the corners are 90. So that means this angle here is 90. And if you just look at this triangle right here, you have a side that's 6 and you have a side that's 15. And you know this is a right triangle. Well, guess what? There is a thing that we should have learned somewhere in the past called the Pythagorean theorem. What you can use when you have a right triangle is Pythagorean theorem. You can use that. And so if you remember, that formula was a squared plus b squared equals c squared. So we're going to use that formula. Keep in mind, here's the trickiest thing. A lot of times people forget which one's A, which one's B, which one's C. All right. Just remember this. A and B are just the two sides that make up the 90-degree angle. So A and B is 6 and whatever side we're missing here. Okay? So C is always the one that's across from the 90 degrees. So A and B make up the 90 degrees, and C is across from 90. So let's call 6, let's call that the A. It doesn't matter which one's A and which one's B. Let's call that one A and call this one B and call this one C. Okay? So let's plug it in. A squared, which would be what? 6 squared plus B squared equals 15 squared. All right, let's work all that stuff out now. So, well, first of all, 6 squared, we know that one, right? 36. And 15 squared will be 225. Minus 36. Yeah, it gives me 189, so b squared equals 189. And then, can you remember, how do we get rid of something that's squared? How do we get rid of that square? What's opposite of squaring something? It's taking the square root. So I'm going to take the square root. That will cross out, the square root crosses out the square there. But I have to do it over here as well. And so then if I take the square root of 189, it doesn't come out evenly, but you know what it says? It says it's approximately, I'm going to round it to 1 decimal place, 13.7. And so what that means is B is FG, and so FG is approximately 13.7 feet. Okay, so that is something that you can use here as well. Because of the 90-degree angle, so you can use the Pythagorean theorem. So that's another thing to think about. Okay. Example 2a here. We have a rectangle. RTU is 8x plus 4. Well, let's see. RTU. So that's right in here. This angle right in here. So this is 8x plus 4. SUR is 3x minus 2. That's this one down here. Find x. Okay. Well, remember, think back to what I said at the beginning of this. We said, since this is a rectangle, remember, all of these pieces are congruent, right? And so if you think about this triangle right here, it's an isosceles triangle. So if these two are the sides that are congruent, across from it is 8x plus 4. Well, across from this one has to also be 8x plus 4. So that means this angle down here is also 8x plus 4. Well, if you do that and write that in there, then you notice, hey, guess what? These two angles together make 90 degrees. Okay, so our equation that we're going to write here is what? 3x minus 2 plus 8x plus 4 equals 90. So we just add those two together to equal 90. Okay? Combine like terms, 3x and 8x would be 11x. 4 minus 2 is 2. And then we subtract 2. So 11x equals 88. Divide by 11. And it looks like x is 8. Okay? Good. Feel okay with that? Excellent. All right, example 2b. How about this one now? Again, we got some angles. Let's write stuff in here. FGE is 6x. Here's FGE, 6x. I'm going to put an arrow here. 6x minus 5. GEF is this one right here. 4x minus 5. Find x. Okay. Well, again, we go, well, this is a little bit different than that last one, because before I knew that, these were going to be the same. Well, if you think back, beginning of the year, we talked about if you have parallel lines and you have a line that cuts through it, a transversal. And if you notice, that's what's happening here. In a rectangle, we have parallel lines, and this line cuts across it. So if you remember, one of those things that we knew that were equal to each other or congruent were alternate interior angles. Okay, so remember, alternate interior angles. So that's what we have here, is we say, well, what do we have that's alternate interior angles? Where's my pen? There it is. So if these are the parallel lines, GF and HE, from this one here, alternate interior, or actually it'd be the other way around. Look at FE and GH as being the parallel lines. So alternate interior to this one here would be this one up here. So that means this is also 4x minus 5 right up in here. And guess what? Now we have the same thing where the two of those together will equal 90. So we would just say 6x minus 5 plus 4x minus 5 equals 90. 6 and 4 is 10x. Negative 5 and negative 5 is minus 10. Then we add 10. 10x equals 100 and divide by 10. So x is 10. Okay? All right, feel okay with that? How about this one? Now we're talking about the side. So SP is this part of the diagonal here. So it's 5x plus 4. And PT is this one over here, 3x plus 10. What could we do there? Well, remember, since the diagonals are congruent, each half of each diagonal are congruent as well. So in this case, 5x plus 4 has to equal 3x plus 10. Minus 3x minus 4. 2x equals 6 and divide by 2, so we have x equals 3. Okay? I'm kind of going through a few of these kind of quickly, but just because of our time situation. All right, real quick, just kind of a thinking one here. Max is building a swimming pool in his backyard. He measures the length and the width of the pool so that opposite sides are parallel, which it's marked. He measures the diagonals to make sure that they're congruent. How does he know that these are going to be 90-degree angles? In other words, how do we know that this has to be a rectangle? Well, since opposite sides are parallel, it must be a rectangle. Well, actually, couldn't a parallelogram have opposite sides parallel? Yeah, so it's not that one. Opposite sides are congruent, it must be a rectangle. Well, that could also be true for a parallelogram as well, so it's not that. Of course, D says it's not a rectangle, maybe, but let's look at C. Since the diagonals are congruent, it must be a rectangle. That's one of the things that makes something a rectangle, is if the diagonals are congruent. So that would be C. Good. So example 4, coordinate geometry. Last problem here. We've done a little coordinate geometry before, and I have to get my thing back here. We've done a little of this before. I don't think we've ever used the distance formula, and so let's take a look at that. Remember, the distance formula will be x2 minus x1 squared plus y2 minus y1 squared. Again, remember, you know, if you end up putting the y minus y first and the x minus x second, or if you do x1 minus x2, y1 minus y2, it doesn't really matter. It's all going to come out the same anyway. So what we want to do, though, is there are two kind of steps that we need to do. The first step to prove that this is a rectangle or not, we have to first figure out if it is it a parallelogram. Okay, so that's our first step. We have to figure out, is this a parallelogram? If it's not a parallelogram, it can't be a rectangle. So we have to figure out, is it a parallelogram first? So using the distance formula on a parallelogram, remember the opposite sides are congruent. So the first thing we have to do is figure out the distance from, say, j to k and m to l. If those are the same distance, great. Okay. If not, if they're not the same distance, then we know this is not a parallelogram and we're done. But let's start with jk. So let's fill in here. We've got jk, so I'm going to go -2 minus 1 squared, 3 minus 4 squared. So -2 minus 1 is a -3 squared, which is 9. 3 minus 4 is a -1. -1 squared is 1. So this will be the square root of 10. You don't have to get the decimal here. We're just going to compare it to the other side. And so we just want to leave it like that. That's easiest to do. LM then, so we just did JK up here. Now we're going to do LM. And so if we're going to do LM, I'm going to go 3 minus 0 squared, and then -2 minus a negative or plus 3. -2 plus 3. So this will be 3 minus 0 is 3. 3 squared is 9. -2 plus 3 is 1. 1 squared is 1. Guess what? We've got the same thing. Okay, so what this proves is that those two are the same, so that means this side and this side are congruent. All right, now since we know that side's congruent, now we have to continue on. Now we have to look at the two long sides. So let's look at JM first. So JM, I'm going to go -2 minus 0. -2 minus 0. And then I'm going to go 3 minus a negative, or 3 plus 3. All right, so -2 squared would be 4. 3 plus 3 is 6. 6 squared is 36. So that's going to be the square root of 40. And if we're looking at JM, then we also have to look at KL. All right, so KL this time, I'm going to go -1, or I'm going to go, sorry, +1 minus 3. And then 4 plus 2. So that's 1 minus 3, -2 squared is 4. 4 plus 2 is 6. 6 squared is 36. Square root of 40, guess what? Those are the same. So that means, so now what we've done here, so far what we've shown is, yes, this is a parallelogram. If these both don't match up, we would have to say, nope, it's not a parallelogram, so it's not a rectangle. All right, but if these both match up, which they do, we have to do one more step. And so that's why, fortunately, I made one more slide that we can go to here. It's all the same information here, but since we've figured out if it's a parallelogram, the other thing now we figure out, is it a rectangle? And so now that we know it's a parallelogram, what's different about a rectangle? Well, what's different about a rectangle from a regular parallelogram are the diagonals are congruent. So from that diagonal and that diagonal are going to be congruent to each other. So they have to be the same distance. So now what we're going to do is we're going to compare two more things, JL and KM. So let's start with JL. So if I do JL, it's going to be what? Negative 2 minus 3. And then 3 minus a negative, or 3 plus 2. So that's negative 5 squared, which is 25, and 5 squared, which is another 25, so square root of 50. And then let's also look at Km. And so Km, it's going to be 1 minus 0. And then 4 minus a negative, or 4 plus 3 squared. And so that's 1 squared is 1, and 7 squared is 49. And guess what? Oh, look at that. They're the same. And so what that means is, since these are the same, now we can say without a doubt, yes, this is a rectangle. And I'm even going to give 3 exclamation points because that was very challenging. All right, anyway, that's it. You can kind of see there are other ways that you could approach this as well, using maybe the slope formula, but I wanted to show you distance today. So that's going to do it for me today. This is Mr. Anderson signing off, and we'll see you next time. Bye.